So I'm gonna pull a different one. So I'm gonna pull a different one so you guys can all practice on a certain thing. So far as the MCQ goes, MCQ they will give a function like says um can you guys see my iPad or no?
Yeah.
Okay, so MCQ is gonna happen like this: d to the dx of, let's just say, I don't know, x squared sine of x, something like this, of, I don't know, square root 1 minus t squared dt, something like this. So they will ask you, says, okay, of course this is more extreme case, usually it's 0 on the bottom, so you cannot take integral of this, so you're gonna say this one is a small g of x. If d to the dx of small g of x dx, or d of t actually, we're gonna assume that's g of t between sine of x and x squared. So if I do integration of that, that's gonna be, this is called the first part of fundamental theorem calculus. So this one is gonna be g of x squared minus g of sine of x. So you integrate small g, become big G, but you're going to take a derivative again. So it's going to be g of x squared times 2x minus g of sine of x times derivative of that is cosine of x. Now you just have to plug in back. They say g of t is equal to square root 1 minus t squared. Now I'm going to plug it back in there. So it's going to be square root of 1 minus x to the 4 times 2x minus square root of 1 minus sine square root of x times cosine of x. So that will be your final answer, but this is what MCQ would ask you. But for FRQ is a tiny bit different. So what we're gonna do is maybe we can come up with an example question, because the so 2000 we're gonna see if 2017 FRQ has a question like this, and maybe you guys can practice. Let me see if I can find it. Yep, we do have a 2017. And this is a good question to review the day before the test, because this is a question that more likely to show. So what we're gonna do is you guys on Twitch or you guys on YouTube, you can see the questions. You guys, can you see it? So this is a completely different question than before. You guys never did this question, so it's good practice. Do you think it would be better if I post on the Emoto?
Yeah.
Yeah.
Let me do that. So Emoto is already have a multiple choice question. I already have a thing. So let me see that. So this is just an extra practice of fundamental theorem calculus. But they put an extension to that, of course. So that's a good practice for all the cases. So desktop, untitled folder, 2017 AVFRQ. Here it is. So I'm gonna give you guys 10 minutes to finish this one. I'm not gonna give you more than 15 minutes because this question should not take that long. There was a 3-part. Actually, there was a 4-part. Do you guys see it?
Mister, what number is it?
Number 3. Now, fundamental theorem of calculus it's a must, right? Now, I do think there's other question better than this one, and the best one I think is the 2017 one. Like last time you guys were in tutoring, you guys did that one. Um, so they kind of hit two bird one stone, ask you average rate of change, a little bit of fundamental theorem calculus. They didn't ask the second part of it, but we're gonna talk about the second part because I think the second part is better. The other part is better, but this is other questions. Oh, anybody have calculator battery issue tomorrow? Please let me know. I'm gonna have to find a way to give you a new calculator or find a way to anybody batteries not charged? I should send out a reminder, right? I'm gonna do that. Remind everybody to charge their battery. Okay, please charge your calculator. Charge your calculator. And make sure after the test, give me back the loan calculator, loaner. I don't want to have to pay for it. Please charge your calculator. Or if you need charge your calculator, come to school early. So this one doesn't have initial conditions, so for me it's a little bit easier. I like the one with the initial conditions. So, which is 2017, I think question 4, question 3, I don't remember. Only in the first part is fundamental theorem calculus. Okay, Delilah, since you asked this one, do you know how to do the first part?
I know how to do the other parts, but I don't know the first part because it asks for the average rate of change from -5 to 5, but the integral starts at 1. So I'm confused.
Okay, good. So that's what we're here for. So how many people have problem with first part? Do you want me to give you answers first? Or still somebody still working on it? Frida, what'd you get for first part?
I don't think it's right, but I got 19 plus pi over 10 because I remember average rate of change is but it's I thought there was like 2 ways of doing it, but every time I see average, my brain explodes, so it could be wrong.
Okay, so the way to think about average rate of change is the slope. That's probably easiest way to think. When you think about instantaneous rate of change, it's derivative. And when you say average value, that's where you do integral.
Okay.
Okay. Lucia, what'd you get for first part? Oh, you have not done yet. Oh, if you don't know the answer, just tell me.
Yeah, I finished it.
What'd you get?
I got -6 plus pi over 10.
-6 plus pi over 10. That's a little bit off. Okay, let me ask. It's okay. That's why we're here for. That's what the reason why I asked you is I want to see what you guys not. I just want to see what you guys get. Bath, what'd you get?
I'm still doing part A.
Okay, Clydesdale, what'd you get?
So I had a fraction on the top, so I multiplied it, so then it became 2 pi minus 17 over 20.
Okay. So this question seems like a little bit off for everybody, so that's good that we picked the right question. I just want to see if I pick the right question for you guys to go over. Priya, what'd you get? Priya?
I got 5 minus pi over 10.
5 minus pi over 10 is a correct answer. Okay, and that's okay. That's what we're here for, though, so we can fix those mistakes. So what we're gonna do is, if you can see, so what we're gonna do is we're gonna look at here, and we're gonna look at the graph at the same time. So it's gonna be g of 5 minus g of -5 over 5 minus -5. So that's equal to 10, right? Of g of 5 minus g of -5. Does that make sense? And then you can go into define g of 5 is. So I'm going to pull the graph back out. I'm going to say, hey, I'm going to look at the graph. G of 5 is, so they say g of x is equal to integration from 1 to x of ft dt. So then the graph is f. So that means I'm looking at integration from 1 to 5 of ft dt. So that means integration from 1 to 5. But from 1 to 5, it's going to give me something like, it's going to give me like something like 12. Do you know why it's 12? Because the graph is like this, and the graph is like this, and it's gonna go like this. So basically start at 1 and go in here and go in here and go in 2 more units. So basically just area under the curve from this point 1 to 5. So basically there was 8, 9, 10, 11, and 12. Do you see why that's 12?
Yeah.
Okay, so then that would be 12. Now I'm gonna figure out what a g of -5 is. So you're gonna try to find out what happened between 1 to -5 of ft here dt is going to be by looking at the graph. So if you did it right, I think you would get. Okay, I'm gonna ask somebody. What is g of -5? Anybody want to share with me the answer?
The answer that you get is -7 minus 5.
-7.
I mean, no. Yeah.
7 plus pi.
Because
It's
everything's negative. It's underneath the.
I got 7 plus pi.
7 plus pi is right.
Oh, I put it in my work because I.
It's negative, but we're going backwards, so then it's positive.
Yeah, so that's okay. So that's a very dangerous way to look at it. Be careful with that way. So what did it not? That's a dangerous way to look at it because sometimes your brain doesn't really form correctly. But if you got a right answer, it's great. But for me, like I always keep the same orientation from left to right. So I keep this one as a minus in the front, and from -5 to 1 of ft dt. I keep it like that. So that way I know it's below x-axis is negative. Does that make sense? So it's going to be negative. And by looking at the graph, I think that is 3 times 4. Wait, hold on a second. Let me look at the graph correctly. Yeah, 3 times -5. Yeah, 3 times 4 over 2, right? So it'll be 6. Wait, what the heck is 6? Oh yes, it's 6. And then that's a negative. This is a negative because this is below x-axis, and also -1, and also a negative pi. So because that's equal to negative, this one is gonna be 3 times 2 is -6, so it's -7 -pi. And if I distribute, that's going to become 7 plus pi. So if I do 12 minus 7 plus pi over 10, so that's is a pi. So that's going to be 5 minus pi over 10. So that's going to be an average value. So I'm going to write down here is equal to that. Now for me, what did I say? It's going backward. That means it's the opposite. So for me, my brain doesn't wire that way. So I cannot think that far ahead. So I will change the orientation. I'll distribute negative sign, even though it's more confusing. But I still worry about is just have to worry about is below x-axis is negative, is above x is positive. Did anybody have a question where I got that? Do you guys need more practice on this type of questions?
Could you go over the rest of the FRQ just to see if we got the other parts right?
Okay, sure. So they say find the instant rate of change of g respect to x. So you just have to write down g prime of 3 is equal to f of 3. Do you guys understand that part?
Yeah.
So at 3, what do you think the answer is?
I got 4.
You got 4?
Me too.
Okay, so that's equal to 4. Yep, that's correct. 1 point for that. But this is the biggest point. Okay, so let's go to the next one. They say open interval g is concave up. That means g double prime of x is equal to f prime of x. That means I'm looking at the concave. I'm looking at the graph and look at where it's increasing. So if I'm going to look at increasing, I'm going to go back here. I say increasing from -5 to -2 and from 0 to 3. And it's going to be parentheses. You should not including the endpoints because the endpoint doesn't mean it's, yeah. You should not include a scoring guideline. Did not include. I didn't include either. Am I going too fast?
No, you're fine.
Okay, find the x value interval of -5 5, which g has critical point. Clarify each critical point as a location of local minimum and local max, or neither. So from -5 to 5, we're gonna go back and look at the graph. And -5 to 5, that means, wait, what are they looking for? They're looking for g has a critical point. So g, that means g prime of x equal to 0. That means f of x is equal to 0, which is happened at -2 and 1. -2 is neither max or min because it did not change in sign, and that 1 is a minimum maximum.
So it could be a critical point without being a max or a min?
Yes, of course. So what the definition of critical point is this. The definition of critical point is it's just basically derivative equal to 0. So that's why when it's on the AP exam, it's very important that you test you test the number line test to see if there was a sign change. If there's a sign change, that's qualified for maximum min, and same thing for inflection points as well. And that's how you get all 9 points. And I think the biggest struggle is always coming from the first part when they try to evaluate that area situations.
Isn't it minimum because it goes from negative to positive?
Oh yeah, it's a minimum to positive, yes. At x equal to 1, but x equal to -2 didn't really change the signs. So therefore you cannot say that.
Okay.
And you have to justify, you have to say it's f of x changing from negative to positive at x equal to 1. And f of x equal to g prime of x. Therefore, that's a minimum.
So you don't have to justify with a table. You can just justify with an explanation. That's it.
Okay, so only time you need to justify with a table is absolute max and absolute min, not a relative min and relative max. Wait, what did the question ask? Let me check the question. Maybe I didn't answer the question completely.
I think it's
They only want a critical point. They didn't want an endpoint. So they only want a critical point. So that's relative. Local. See, they even say local min and local max. That means relative. So relative is anything between the interval. Now, if it says absolute, that means including the endpoint evaluations. How are you doing about this part? So the hardest part I feel like is the first part. At rest of the part, you guys get pretty experienced on the rest of the part. At just the first part, like count the areas that you guys still struggling. And especially, this is not a one with initial condition. If initial condition is a little bit harder. Let me see if I can find one that's initial condition. And you only need to practice one part. You don't need to practice all the part because that's a part that usually set people struggle.
Was A worth the most amount of points?
Usually that was 3 points there, and but in this case it's only worth 2, so it's not that bad. But still, it's something that I think I will consider this as an easy point to get. Especially you just have to know how to do the right thing. So how about this? I'm gonna post this. F-5. Okay. I want you to do 2018, just the first part. Now, 2018, just the first part. This one including the initial condition. Isabel is asking what is initial condition? Why is initial condition so important? But if you look at the question, let me post this question on the group chat. Maybe it's easier, or what's the easiest way?
Group or remote.
Yeah,
Yeah,
group.
mode.
Hold on. For me, I can do it really fast. I'll see if I can do it on Modo. Let me put on the group chat. Or you can just go to your computer, look up 2018 question 3. Question 3 part A, only part A. Only part A, not anything else. Wait, hold on. Yeah, only part A. Part B is kind of difficult. Only part A. I think those are the small amount of calculation. Like part B is a lot of calculation. So 2018 part A is the calculation that I will want you to easily get those points. And that's to answer your question for fundamental theorem calculus. So let me post it right here. It'll be easier to do it here. AP.
Part A.
Yeah, 2018. AP 2018. AP calculus. And part A. Let's see if this time I don't want to ask 5 people and 5 people got it wrong. I want to ask 5 people, 5 people got it right. But this one is a little different because this one has an initial condition. So you have to worry about initial condition. I know Priya will get it right. I know Trent will get it right. But I need the rest of you guys get it right as well. So a lot of you guys all depends on what to do with the initial condition. This is the part that you really need to apply fundamental theorem calculus 1 to help you get those points. I forgot how many points this one worth. I think this is 2.
Did you post the question or do we have to search it up?
You can see on my screen. It's probably, you can tell from the screen. You don't have to search it up. But if you search it up, it's 2018. But it's right in front of you. You should be able to see my screen, right? Oh no. Sorry. You should see a screen on Twitch. You see the screen on Twitch.
I put it in the Zoom chat as well. The link to the.
Oh, you did? Okay, thank you.
Thank you.
Yeah, Miguel is really fast about that. So this one's with the initial condition. So, and I always told students, initial condition always put, and they will ask this question MCQ as well, so it's worth it to talk about. In MCQ, except they will give it in the term on the calculator section or non-calculator section, both. And if you already get this, you can move on with other multiple choice. You can get rid of the question to ask me so I can answer other questions. So like Trent and Priya says, I don't need to practice with this. Then you just go to other question and figure out other question to ask. So as soon as we finish this one, we can answer your question. So that way it's going to be efficient on the time. Sorry, I didn't
Number 1, right?
Huh?
Is it number 1?
Number 3.
3.
2018, number 3.
Part A.
Part A. So this question right on the Twitch. But yeah, go ahead and work on different question because I know you already got this. Trend 2. Franco. Go to the question you don't know and need to answer. You guys almost finished? Lucia finished?
I'm trying to look it up because you took it off the screen, but just like 30 more seconds.
It's in the chat.
Oop. I'll click there now.
So this one's a little bit different than last one because this one has initial conditions. and they didn't tell you which integral you had to take. Can you close the door? Can you close the door?
And immediately died. So this one blended it. Blended their attack on.
And this is worth 2 points, but the calculation is not that bad. It's very easy. The answer is going to be fraction, and numerator plus denominator is equal to 27. So it could be like, I don't know, 13 plus 14, 13 over 14. I don't know. Just an example. But if you did it right, it's a combination, it's going to be 27. Now, why did I go over this question? This question is on MCQ and FRQ, and we're going to talk about in different cases. Kliza, you got it?
Yeah.
You got 27, numerator plus denominator?
Yeah.
Okay, good. Lucia?
Yep.
Good, good, good. Fida?
Yeah.
Good, that's awesome. Okay. I don't know who else is here. Miguel?
Yeah, I got an answer.
Andrea?
Yeah, I got it.
Chinese?
Yeah.
Delilah?
No, I don't get it.
Okay, that's okay. That's why I told you to be here, because I can tell you what kind of variation on that. If you scream on the YouTube, they don't know what kind of variation can happen. So this is the second type of variation. There's a third type of variation too. They don't give you the graph. They give you like some weird graph, and they just say the area is 5, the area is 3. And below x-axis, the area is going to be negative when you take an integral. So this is the type of things that can happen. So what happened is, what you're going to do is, this is the function g, right? And if I integral of g, that's equal to f. That's the first thing you have to see. They say the g is the derivative of function f is shown above. So if you integrate the g, that should give me a f. So integration of g of x dx, it should give me a f of x. Especially there is boundaries. Now what happened is, I'm going to choose my boundary. They say f of 1 is equal to 3. So this is a 1. And this is a -5. Does that make sense? And if I do integral of that, I know if I integral of g, it's going to give me f. So then that's just going to be f of -5 minus f of 1. Now, as crazy as this sound, this is just a fundamental theorem of calculus. You don't even have to evaluate it. You just write like this. You earn yourself a 1 point. You don't even have to know how to calculate area underneath. You just, by writing down the fundamental theorem of calculus 1, it will earn you 1 point. So even you didn't know how to do it, if you write down this, you get 1 point. Why? Because you had to decide the interval from 1 to -5, and you had to say f of -5 minus f of 1. Now, can you change that around? You can. Then you have to do the other way. It's probably better to do the other way anyway. So I'm just gonna assume, and we're gonna keep like this. This one's gonna be negative of -5 to 1 of g of x dx is equal to f of -5. And f of 1 is 3. So it's going to be minus 3 is going to be positive 3. So this one is negative 3 here. If you move to the other side, it becomes positive 3. So g of negative 5 is equal to 3 minus integration of negative 5 to 1 of g of x dx. So then you just have to calculate area from negative 5 to 1. Okay, negative 5 to 1 is going to be 3 minus, this one's going to be 9 plus, oh, that's below x-axis, so it's going to be minus 9 plus 3 over 2 and to 1, right? Okay, so it will be negative 9 minus 3 over 2 and then plus 1. So it'll be 3 minus, this one is going to be negative 8, negative 9.5.
Wait, what did you do with the f of negative 5?
That's what we're trying to evaluate. I move this to the other side, become 3. So it becomes f of negative 5, which is, that's what we're trying to evaluate. So by writing down this, you get 1 point. Do you understand that part?
Yeah, I got that.
Okay. F of 1 is, they told you, is 3. So if you move negative 3 to the other side, it becomes positive 3. So it'll be 12.5 over 2. And what, did I do something wrong? Hold on a second. Did I do something wrong? Let me see. Can somebody check my math? There's something wrong. Negative 9. It's going to be 12.5. 12.5 is 25 over 2. Oh yeah, 25 over 2 is right. 25 over 2. Okay, next question. So this is one with fundamental theorem calculus. Write down this part here. It will give you all the point. It will give you all the point, and also give you the map to help you solve the rest of the part. Okay, next question. Do you have other questions? So I answered Delilah's question. Other people have questions?
Can I ask one more thing about this question?
Sure.
So I get why, like, I get the boundaries and making that the equation, but why are those the boundaries for the fundamental theorem of calculus? Like, why did we put 1 and negative 5? Like, how does that work with the graph?
Because when you integrate something, there is probably a c value, right? But in this case, we don't have a c value because I'm trying to think about. Can you rephrase your question? Maybe other people can help me answer this question as well. So I don't know. Like, can you say the question again? Let me see if I can understand it better.
Sure. So basically, it says f of 1 is equal to 3, and then it says we're looking for f of negative 5. But I'm wondering why the 1 and the negative 5 would be the boundaries for the for plugging into the equation. Like, I don't get why we would use those in relation to g of x.
Because when you integrate of f, it's gonna give me g. But the f of 1, it give you kind of a starting point for you to kind of see things. And the f of negative 5 is the end point. Because if you integrate, so that if you see here, right? If you integrate something between 1 to negative 5, in this part, it's going to give you f of negative 5, which is what you're trying to evaluate. And f of 1 is giving. So you have to decide your boundary to be there. If you decide other boundary is not going to helpful to you. Because first of all, if you choose from 2 to negative 5, but the problem is we don't have f of 2 value.
Yeah, that makes sense because f of x is the integral of g of x, right?
Yes.
Okay, got it.
Okay, other people have other questions? I'm trying to answer as many questions as possible so you guys can go and just shoot a question over. We can answer it because if I think it's relevant, I'll answer it. And fundamental theorem is relevant. It's probably the only thing that's relevant on this test.
For the separation of variable question.
Which one?
One of the point. Oh, it was 2019 one. Number 4.
Got it.
One of the point was like constant of integration. What is that?
Let me see. It's the one on the AP.
College board, like the same question that I asked earlier for number 6.
Okay, let me get there. So question 6, 2019, right?
No, 4. I was just asking like what is constant of integration?
Number 4 is cylindrical question though.
Yeah, but for part C. No, I'm looking at like the scoring guideline. And they give 1 point for constant of integration.
Oh, that's the C value.
C? Okay.
Other questions? If you don't ask, you get a chance.
I have a question that's like about the exam. Like, do you have any predictions about what the FRQ is gonna be like, or like what topic it'll go over, other than like fundamental theorem of calculus?
Yeah, it's Are you on Twitch right now? I showed you last time. I actually write it with you last time.
Oh yeah. I think I have a screenshot of it.
No, I have a better shot at this here. If you look at Twitch, then you can see it. Or YouTube Live. This is kind of a small setting. So as I said before, FRQ, pay attention initial condition and domain always. Pay attention to units, feet per hour, feet per square foot, 3 decimal place, number line of test is not justification. This is also on the other one. Table is justification for absolute max and min. Endpoint evaluation as well as critical point evaluation. Don't graph the y equal to integral. Yeah, do not put an integral sign on the graphing calculator on the graphing part of the equation part, like y1 equal to. Do not put an integration sign over there. That's not where it's supposed to go. I think a lot of people slow down the calculator by doing that. So don't ever do that. The first question is going to be fundamental theorem calculus and analyze f of x, f prime of x, f double prime of x, which is we just talked about. Differential equation, there's equation tangent line approximation, slope field, look for the zero slope first. Differential equation with the initial condition 5 to 6 points. And over approximation, under approximation by looking at the concavities. So that may be the second one. If you look at a Twitch, the third one is going to be motion. It's going to be speed increase, speed decrease. When a particle at rest, also, hold on, let me put something. Also, particle changing direction. Or changing direction. V of t is equal to 0. Average velocity, there's 2-way. Average acceleration is 1-way. Total distance and total displacement without initial condition. Further right, further left. That means as absolute maximum min about the velocity function. Net rate is for sure. Almost for sure the guarantee to have net rate. I don't know why they like that one a lot. But net rate, yesterday on tutoring we talking about when they ask you when they ask you minimum, just graph the in rate minus out rate. Do not do anything about integration. Integration is defining the amount. Area and volume is the 5th one. which is area and cross sections, volumes, and stuff like that. 6, the right end Riemann sum, left end Riemann sum, midpoint. Trapezoid rule, overestimate if you have right, yada 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 yada. So that's my prediction for 6 questions here. Now they can have more, so I'm gonna put down a subtopic. The subtopic is implicit derivative.
What year has FRQs about net rate?
Huh?
What year has an FRQ about net rate so I can look at it?
2012 has a gravel one, I think.
Can you look at every year has a net rate? Which one? I mean, every year has one.
Everyone. So you can just... Yeah, almost everyone every year has one. Yeah. But there was a gravel one. In 2012 or 2000. I mean, pretty much every year, 2012 to 2015. Those you just look at, you skim through, you're gonna see a net rate questions. Now there was a subtopic like continuous, right? Continuous and differentiable. There was one that we did the 2019 on my AP classroom. That's the odd topics. So if you want to do the last minute practice, but definitely the last minute is good practice. So what I mean is last minute is this one. Last minute. I'm talking about this one. Don't worry about the first three. The first three is FRQ practice and differential equation practice. Yeah, the first three has the L-Hopper rule and differential equation practice. They are BC practice, but they have L-Hopper rule, so they have more example. This one is about differential equation, but it's a little bit worded differently. 2011. Net rate, there's a one here. This one is 2015. And we went over this one in particular. And this question, so all these questions here, the last minute is very good. It's very, very excellent practice. Especially number 6 also, I think there's a new trend of new questions. So this one I'm going to put as notation fluency. And this is notation fluency questions. Because notation fluency has example of table, chart, and equation. And the equation usually have to deal with something with chain rule. And they love this question now. 2017 question 6. This is a very good one. Question 4, 2018 is trapezoid rules, average rate of change, and just miscellaneous stuff. And we talked about this one already. So this one's similar to the last one. It's just a different example. So yeah, every year there's a net rate questions. Other question, multiple choice FRQ. Any other questions? The last minute one is really good practice. If you want a last minute practice, this is probably the sums up a lot of things.
Miguel wrote in the chat that he wants to do an FRQ about velocity.
Sure. I just saw one earlier. Hold on. Actually, I want to do a different one about velocity. The recent exam has a 2-particle one. And they kind of put it different way. So okay, so for you, for the data, you can go to 2019. Look at question 1. There was one about fish. Fish in the pond. I think you will like that one.
For net rate?
Yeah.
Okay.
Kind of cute. Fish go in the pond and fish go out of the pond. They really run out of topic. Miguel, if you want a hard one, is 2019, but this one is combination of motion and other topics, which is kind of weird. Um, um, 2019. This is a weird one. I don't like this one, but it's really hard to read. But there was two particles, and they seem like they that's two particle a lot recently. Let me see. Let me see if there's a better one for two particle one. Let me check. Okay, 2018. Okay, 2018 is more reasonable. I think 2019 is kind of hard to read. You can do 2018 question 2. And that's with the calculator, so it should be pretty fast. And then you can look at the scoring guide and see which part you don't get. Miguel, you got it? Anybody else? Any other requests? So 2019 has one is the chart and table. I think that one's not good practice. The chance of that one showing up again is not likely. But 2018 is a better one, Miguel. Any other question on multiple choice for response? Lucia, do you have any question? Andrea, do you have any questions? I don't know if they're here. Andrea's here. Tinese, do you have any questions?
I have to go now, Mr. Ye. Thank you for helping me.
See you. Okay, bye.
Yeah, I think I'm going to. I'm gonna do a bunch of practice tests. And then...
I actually like suggest you just go sleep.
Really? I was planning on taking like 1.5 full tests.
Oh no, don't do it today. This is just too much torture today. There's no point of doing that today. If you do it as much as right now, then it should be fine. But the more you do it right now at today is probably gonna be counterproductive. I mean that's the way my view is. It's a today should be the day to relax and just take the test tomorrow, just so that way you can stay focused. Because if you do too much, it's just you can stay focused tomorrow. But yeah, give yourself a nap and just kind of look over the things that you need to study, which is the calculus cheat sheet really helps. But yeah, that's what I do. But you can do whatever you want. I mean, I'm just not a good. I don't think the last minute is going to be very, very, very helpful because it's going to be counterproductive than productive. But look at over all the things, probably something that's kind of important. Because every question is going to be different tomorrow.
Okay, I guess I'm gonna take a nap then.
Yeah, take a nap. I think it's fine. I mean, you know, I want to work hard before, but today is like not the day to work hard. But you clear out a lot of misunderstanding, right?
Yeah, I
Okay.
think I can do better now. I'm not stopping as much with like the questions.
Right. Okay, so tomorrow when you see question that you struggle with it, just breathe in and breathe out and says, you know, I can do this. And if you really cannot do it, move on and come back to it. It's because your brain still processing about that question. So sometimes you do other question, you figure out how to do a certain questions. So
Yeah, okay. Thank you.
all right. No
Thank you,
problem.
Mister. Bye.
No problem. Good
Bye,
luck.
everyone. Good
I'll
luck.
see you tomorrow.
Bye. I expect some good donuts. Or pizza. Oh wait, no pizza. My bad.
Pizza for sure because pizza is for sure. Um, wait, today's which day? Today is what? Monday.
Monday.
Okay.
But yeah, bye.
Bye.
Bye. Have a good day.
You too.
Bye. Thanks for the help.
Mr. Yang?
Yeah.
I heard you were talking about a calc cheat sheet. Is it the one that you sent like a while back with everything, or is it something different?
I just sent it again today.
Where did you send it exactly?
A model.
Oh, okay. Yeah, I'll look over that. Sorry, I had to join tutoring late. But I'll look over that, and I'm gonna go and review like a couple of topics. Okay. See you tomorrow, Mr. Bye.
Okay.